So the last thing we're going to do before we have our quiz is cover segments and angle measure. All right, segments and angle measure. The first thing's pretty straightforward, the ruler postulate. Every point on a line can be placed on a one-to-one correspondence with a real number. All right, so this is why we have rulers, because you are basically just measuring a line segment when you have a ruler or a measuring tape. And they're just saying that a line segment can be measured. So you can have the line segment AB. A can be at the point 2, B can be at the point 5, and you can measure the distance between the two. So the coordinate of the point, that definition, is the number that corresponds to that point. So the coordinate of the point on a number line is the number that corresponds to that point. Just like when you graphed on the coordinate plane, you would have an XY that would define where it was. Your coordinate tells you where it is located on the number line. So let's talk about what length means. The length of AB is the distance between the endpoints. You'll notice that the formula they have here is that you subtract the two numbers and you take the absolute value. The reason you take the absolute value is 1, you can subtract either direction, and 2, we're talking about distance, so it is always positive. All right? So when you're talking about the length of a line segment, you're just talking about the distance between the 2 points, meaning you subtract the points and take the absolute value. So they want us to find the length of these segments. The length of BD. So we're going to find B and we're going to find D, all right? And we're going to have the absolute value then of B minus, and D is at 2. So B minus D is -5 minus 2. I'm going to subtract what's -5 minus 2. -7. But my distance is never negative, so I am going to say my distance here is 7. All right, 7. Let's look at A to E. A to E. A, that's going to be at -8, and they want it all the way to E, which is at +3. -8 minus 3 is -11. Absolute value of that then is 11. Pretty easy. E to C. E to C. So that means E is 3. C is -1. 3 minus a -1 is what? 4. So my absolute value here is 4. So the biggest problem you're going to find here is making sure you remember adding and subtracting positives and negatives, right? Adding and subtracting positives and negatives. Distance of a line segment is always positive. I will say, too, that you'll notice that when they are talking about the length of a line segment, they do not have the line segment notation above it. So if I have something that looks like this, AB, I am actually talking about the physical line segment AB, okay? I'll say AB is congruent to something else or whatever. If I'm talking about the length of AB, then I will just list the AB without the line segment above it. That means the measurement of line segment AB. So AB without a notation above it is actually talking about a measure. It's talking about a number, all right? While the notation above it means you're talking about the physical line segment itself, not the length of it. All right, so that's why you'll notice in the formula up here, they do not have the line segment notation above when they are talking about the length of the line segment. Page 27, numbers 4 and 6. 4 has 2 parts there. All right, let's go over these. The first thing they want you to do is just state the coordinate. So the coordinate of K, you would just list 9. Coordinate of K, they just want where it's located on the number line. C then would be 0. For A to F, you should have done the absolute value of A minus F. Right? And then -8 minus a -5 is -3. So the absolute value there would be 3. All All right, so the next term we're going to talk about is congruent segments. Congruent segments are segments with equal length. The symbol for congruence is an equal sign with a little wave above it. So if I were to say that segment AB, I want my notation there, is congruent to segment CD, I want the notation there. What I am saying for that to be true is that the lengths must be equal. So if this is true, then what that means is that the length of AB equals the length of CD. Notice the notation difference, okay? When I am talking about line segments, I would use the term congruence. When I'm talking about length, I'm talking about numbers, so I would use the term equal, okay? Congruence means that two figures have the same shape and size. Equals means I have two numbers that have the same value, okay? So notice my notation difference. This will come into play when we start doing proofs with line segments, all right? You must use the right notation when we start doing proofs with these. So line segment AB is congruent to line segment CD. The length of AB is equal to the length of CD. You'll notice that they have these little dashes right here, all right? Those dashes tell us that those line segments that have the same number of dashes are congruent line segments. That is the notation for congruence in a figure. If you see the dash and the dash, it means they are congruent. All right? And then we have another definition. We've talked about between and what that means a little bit, right? But then they define it a little bit more. If you have a point that is between A and C, and the notation is A dash B dash C, that indicates B falls in between them, then you can add up the two segments and they should equal the whole. This is also called the segment addition postulate. Segment addition postulate says if I have a line segment and there is a point somewhere in the middle of those two, not directly in the middle, but somewhere in between them, then I should be able to add up the first segment and the second segment and I get the whole thing because there's no overlap here. And so they have given me this and they want me to find the rest of them, all right? And so it says, find AB and BC if AC is 75. So what they have told me is the entire length from A to C is 75, and they want me to find the other two lengths. Well, I should be able to say 6x minus 1 plus 5x plus 10, those are my two pieces, should equal my whole. All right, should equal my whole. So we'll just solve. Basic algebra, combine your like terms. What are my like terms here? Negative 1 and 10, and what else? The x's, all right? So my 6x and 5x, what does that equal? They're on the same side, so you just add them. What's 6x plus 5x? 11x. And then my other two like terms, negative 1 and positive 10, what am I going to get there? 9. And then I have a basic equation to solve. How do I solve this? What do I do first? Subtract my 9. I have 11x equals what? 75 minus 9 is? There we go. And then my last step here is to divide by what? So x equals what? Have I finished my question? What did they ask me to solve for? So they wanted me to solve for AB and BC. That means they want the length of AB and the length of BC. I have solved for x. There are going to be times when they may say solve for x, okay? But here they want the lengths of the different segments. So now I need to go back and plug it in. So I want to say, well, AB should equal 6 times x, which we know is 6 minus 1. So what is AB? 35, right? Hopefully. All right. BC then should equal 5 times x, which we know is 6, plus 10. So what is BC? 40. And now I have solved the problem. All right, now I've solved it. Questions on segment addition. Two pieces of the whole, add up. I mean, that's basically what segment addition says. All right, you are using algebra in here, so equation solving is in here. So you will need to pay attention to remember how to solve equations like we did last year. The final definition in this part is midpoint. Midpoint means that it's actually in the middle, exactly what it sounds like, okay? M is the midpoint of xy if xmy, meaning m is in between them, and xm equals my, or xm is congruent to my, okay? So if it is a midpoint, then these two pieces will equal the same. They will be the same length, okay? That means xm will be congruent to my, and it also means the length of xm will equal my. Some more notation here is congruence. They have this little dash on each of the pieces. That one dash to one dash means those pieces are congruent. So you're going to start to see that as a notation. If you see a dash and a dash, then that means they're congruent. It is just like the one we did in the example. For 40, they have told us that it is the midpoint. So they are telling you something about those two lengths by using the word midpoint. So go ahead and try 38 and 40 on page 29. For the first one, they want us to find AB and BC if AC was 44. So you should have added the two pieces and set them equal to 44. All right? All right. 4 and 3. Try this again. 7x plus 2. I was like, why were they so unkind to us here? That was not nice. Oh, this is going to be much nicer. There. Was that better? All right. 4 times 6. Now we got it. What do we get here? 4 times 6 is 24 plus 4 is, there we go. And then 3 times 6 is what? Minus 2 is much nicer. When they told us it was midpoint, they're equal. So you're not going to add these up. First of all, they didn't tell you what the overall length is, so it wouldn't have helped you to add them up, right? If they had told you the overall length, you could have, I guess, but they didn't. So for this one, you actually just need to set them equal to each other. So we need to do this, right? Equal. And so you have 6x minus 20 equals 3x plus 4. All right, and then we're going to get our variables to one side, our numbers to the other. Subtract 3x. All right, we get 3x minus 20 equals 4. And then we're going to add 20. We get 3x equals 24. So what does x equal here? 8. Now, they wanted us to find the length of RS and the length of RT. You actually don't have to plug it into both of them. Why not? Because they're equal to each other. So just pick the easiest one, whatever it is, and plug it in. All right? And so for this one, we know that this is going to be the same as this, right? And then they wanted the whole length. So we don't have to plug it into both and add. What can we do when we just find one? Yeah, just double it, all right? Because they're equal to each other. So plug it in for either one of these. We get 3 times 8 plus 4 was 3 times 8 plus 4. So we know that RS is going to equal 28. All right, so that's this one. And then just double it to get the entire length, R to T. So what is 28 times 2? 56. So you should have gotten 28 and 56, all right? So you can plug it into either one if it's a midpoint, whichever one's easiest to plug it into. Measuring, if you notice in your books here, they have the vertex of the angle at A, and then they have multiple angles that are coming off of it. All right, and so as you have multiple angles coming off of it, you need to decide which set of these you are using. All right, you'll notice on this one, and I'll enlarge it a little bit here and move these out of the way for a second. I have, let's say I'm going to measure angle EAD, okay? I put my center mark on the vertex, and then I look out to the left, and I line this up with one of my rays, in this case, the ray AE. This ray starts at 0, okay? You'll notice I have a 0 and a 180 here. I'm going to start with 0. You always want to start with 0. And then you're going to work your way up to where D is, all right, where this ray ends. This ray ends at 30. That means this is 30 degrees. I have moved 30 degrees from this ray to this ray. Think of it like a pair of scissors opening, okay? A pair of scissors opening. That angle is what is being created. Okay, now let's look at from the angle CAB over here. Let's look at this angle. I still put my center mark on A, and I'm moving over here. Now, instead of using the top line that I used on this side, I'm actually going to use the bottom line here because the bottom line is 0. All right? I always want to start on 0 with whatever I have lined up with the base of my protractor. And then I'm going to look all the way to where my B ends. It ends at 60, which means this is a 60-degree angle, okay? So you need to be familiar with how to use a protractor, all right? How to use a protractor. Here's a clue, all right? Straight up, what is that measurement straight up? What is that angle measurement straight up? 90, it's a right angle, which we're about to discuss. So if you were to measure this guy right here and get 120, which it clearly is marked 120 right there. Everybody see that? You should know you did something wrong because this angle cannot be 120. It is less than 90, very obviously, okay? However, if I were to measure angle EAB, now I'm measuring this angle, okay? All of a sudden, I'm not using 60 anymore because I would have started at 0, and now this is 120, and he is bigger than 90. He's larger than a right angle. Okay, so if I were to ask for the angle measure CAB and you gave me 120, that would be wrong. He's not 120 degrees. But if I were to ask for EAB, that is 120. So pay attention to how you are reading the angle measure on your protractors, okay? Pay attention to how you're reading those, all right? Any questions on using it, all right? On using it, all right? So same concept here with congruence. Congruence segments have the same measure. Congruent angles have the same measure. All right? You use the same symbol. So if I were to make this congruence here, I would say angle X is congruent to angle Y. When I'm talking about measure for angles, the symbol is just putting an M in front of it. So the measure of angle X equals the measure of angle Y. The angles themselves are congruent. Their measurements are equal because measurements are talking about numbers. We're talking about 60 degrees for these particular ones. 60 degrees equals 60 degrees. Angle X is congruent to angle Y. Okay, that's the difference in those notations there. All right. So let's look at another term, adjacent angles. Adjacent angles. Adjacent angle means that they are coplanar angles with a common side but no interior points. So they can't cross over each other. It just means they are side by side and they have a common ray. All right, so adjacent angles here. I have the angle MNK. That is adjacent to KNP. They have a common vertex, which is right here, and they have a common side, which is right there in the center. Now, just like with segments, remember when we had segments, we just did it. You can add them up and you can equal the whole segment. The same thing is true of angle addition, all right? If you have adjacent angles, then the two angles add up to the large one, meaning this angle here plus this angle here should equal the whole thing, all right? Angle addition. If K is in the interior of MNP, that's the large angle, then MNK and KNP, those measures, will add up to the measure of MNP, all right? It just means the two smaller angles will add up to the larger. They will add up to the larger. So let's look at example 4. Find the measure of angle 2, all right? They want the measure of angle 2. So let's see what angle they're talking about. They're talking about this one right here. They have then told me something with this notation, all right? Something with this notation. So let's look at the notation here for congruence, all right? So let's look at the notation for congruence. We have, and it looks like it's just one line, but what they've actually done here is they have told us that angle 1 with this notation, so with line segments, they use a dash. With angles, they use a little arc. So for them to tell me that these two angles are congruent, they would actually use a mark with a little arc there. So they've said that angle 1 is congruent to angle 2, and they've told me that with that notation there. So with that notation, we know that angle 1 is congruent to angle 2, which means we know that the measure of angle 1 equals the measure of angle 2. Well, the first thing they want me to do is they want me to find the measure of angle 2, and they have told me the measure of angle 1. So what's the measure of angle 2 then? If they told me the measure of angle 1. All right? Yeah, it's 55. The two angles are congruent. We know that from the notation, and they told me the measure of one angle. Well, if they're congruent, and I already know what this guy is, then I can say, well, the measure of angle 2 then is 55 degrees. That was an easy one to solve for. That's what they wanted. Now, the next thing they want is they want the measure of angle BAD. That's the whole thing. Well, let's look at what we have. They told us angle 1 is 55. We figured out that angle 2 is 55 because we know they're congruent. So how do we find the measure of the whole? What do? We add them up. So that means the measure of angle BAD should equal 55 plus 55. What's the measure? 110 degrees. All right, angle addition. Angle addition. If you know they're congruent, you automatically know what they equal each other. If you know they're two parts of the whole, you add them up just like we did with our line segment. At the protractor, we talked a little bit about this one angle here, right. Right angles are 90 degrees, all right? Perfect little corner there. The notation for a right angle will always be this little box. So if they give you that little box, you can assume that it is a right angle. You can assume that it is 90 degrees based on that. There are three other types of angles. We have acute. Acute means that it is between 0 and 90 degrees, all right? We have obtuse, which means it's between 90 and 180, so it's bigger than 90. And then we have a special angle called straight. As you can see from what it looks like, it is a line, and the angle measure is 180. The angle measure is 180, all right? So right angles will always have a notation, less than 90, greater than 90, or 180. So let's look at this question. So go ahead and try. Here, use the figure right there for exercises for the number 42, which is what you're doing. And they have told us that EDH is a straight angle. By telling us it's a straight angle, what else did they tell us? They told us its measurement, right? Its measurement is 180. So they want you to use the information that it's a 180 to figure out what the rest of it is. So go ahead and try 42. All right, go ahead and try 42. It says find the measure of angle 3 if 1 is congruent to 2 and 1 equals 43. All right, so they've told us a couple things here. We know that 1 is 43. If it is congruent to 2, what do we know about 2? It is also 43. And then because we know this is a straight angle, what should all of these add up to? 180. So you should have said something like this, 43 plus 43 plus the measure of angle 3, which we don't know, all equals 180. And when you did that, you should have gotten 94, right? 86, subtract your 86 from 180 is 94. Look at this next one. They want the measure of 2 and 3. If 1 is 60, 2 is 7x plus 1, and 3 is 9x plus 7. All we know is they should add up to 180, right? So we should say, for this one, 60 plus 7x plus 1 plus 9x plus 7 equals 180. All right, the first thing you should have done is solve for x, and then they wanted angle 2. So then you would have plugged that in to 7x plus 1 and plug that into 9x plus 7. So your x should have equaled 7 when it's all said and done. X equals 7 here. Plug it in. You would have gotten 50 for 2 and 70 for 3. All right? And on this one, remember you're just combining your like terms and then solving for x. X was 7 here. X equals 7. And then plug it back in.